So, what we're doing today is called Better Lift, and it's going to be pretty close to the code challenge and just kind of investigating whether or not you understand like relationships and how to make like a many-to-many relationship or a one-to-many, something like that, and have each class or model, as I refer to them sometimes, have its own like data and behavior, as we've been talking about. So the other thing about code challenges is they're not actually going to have test specs, because we're evaluating whether you can also test your own code. But one thing you can do, I'm not sure if you've seen this before, you will have an environment set up like this, where you're going to have a folder called tools that has console.rb in it, and it already has like a binding.pry set up for you here. Maybe a useful message like this, where it tells you where you can put variables, so you can actually write some variables in here and test them. So like I put a random variable. During the code challenge, you can put any variables here, and then you'll actually have access to them. So if I wanted to run this file, for example, how would I do it? Yeah, so we hit the binding.pry. If I type Jane, I have access to this variable. And it'll be pulling in the variables from all of your models. Or like it'll be pulling in your models, but then you can instantiate your models through variables and like test them in your pry to make sure your relationships are working and the methods on those relationships are working. So that's kind of what this file is for. Have you guys seen this file before? All right, cool.
So is this like a text editor?
Yes, it's called Sublime. I'm a big fan of Sublime. I can talk all about Sublime and help you set it up if you'd like.
So you don't have to use Sublime, you can use Atom.
You can use Atom. I'm just a rebel. But it'll look basically the same with Atom, all this file structure, right? Because you have your environment that bundles everything together and makes sure you have access to all of your models. Now, I deleted the model files I had in here because it had all of the answers. So, when you get your code challenge, you got to look at your README, right? You're going to get something like this. In fact, let me see if I can pull it up here. I don't know if this is going to be easier to see or not. You'll get something like this, right? Might be a little more aesthetically pleasing. I don't know. But first thing you got to do with any code challenge, read the README. Make sure you know exactly what it's asking. So, we're building something called Better Lift. It's an app for Lyft user or Lyft Uber competitor. And the models we're using are passenger, driver, and ride. So those are like the classes we're going to be building out. So, domain modeling. A passenger will have many rides. A driver has many rides. And a ride belongs to a passenger and a driver. So if we were to draw out this relationship, what would that look like? Would someone like to draw it out? All right, cool, we got a volunteer. Like, what kind of relationship is this?
It's one-to-many for passenger to ride, and also one-to-many to driver. So for passenger
Right, that sounds good. What's the join model in this situation? What would be the class that's in the middle of them both?
passenger will be a ride, because it's dependent on both the passenger and the driver, so that is the same source.
Awesome. All right, can I get that marker? Maybe it works better. We got you another marker. Yeah, and we would call this like a has many through relationship, because a driver has many passengers through rides, and a passenger has many drivers through rides. All right, cool. So driver and passenger is many to many. You can call it many to many. Because in essence, that's what it is. The one in the middle is joining the other two models so that they can have many to many with each other. Alright. Everyone cool with this relationship? There's more? Oh, the chicken feet, of course. Yeah, cool. So driver has many rides, passenger has many rides, and these have many of each other through rides. Awesome. So now we passed the biggest hurdle, which is understanding what the relationship is. You will be surprised how many students, maybe not during this code challenge necessarily, but maybe like during mod 2, will get the relationship wrong, and then how can you continue if your relationship is wrong? So definitely pay attention to this first step, but it should be pretty explicit if you read the README. Alright, so what kind of things are we looking for on passenger? So we want to initialize it with the name as a string. After the passenger has been initialized, it shouldn't be changed. So what does that tell you? That's like a hint. Yeah, so that should be a reader. And then we should have a .name method that returns the name, .rides method that returns all of the ride instances that this person has been in. So another thing to kind of pay attention to when you're reading these methods is like, what should it return? What kind of data type? And it tells you very explicitly that this should be an array, and inside of that array we're going to have ride instances, right? Passenger.drivers is going to return driver instances that that person has rode with. And then we have a total distance method, which returns a number that represents the total distance the passenger has traveled using this ride service. And then passenger.all, pretty standard one that gives you an array of all the passengers. Premium members, so these are passengers who've traveled over 100 miles, and then have an add ride method that allows you to add a new ride. Our ride, this is our join table. Usually the join tables are pretty basic. You want to be able to return the passenger that the ride belongs to, the driver that the ride belongs to, the distance of the ride, which is one of the things it's going to be initialized with. As we can see, it's initialized with a driver, a passenger, and distance as a float number. So like it has a decimal in it. And then average distance. So returns the average distance across all rides. Now looking at this method, it's kind of different from the other ones. Can anyone tell me how? So what makes this one different from the other three?
Yeah, three are just collections of instances. This one takes the data from inside the instance and does something to it.
Yeah, so this one looks at all of the rides, right? And this one only cares about the specific ride instance. We'll get into that a little bit more, but this is a class method. These are instance methods. Kind of a cheater way to figure that out too is that when you see hashtags, you know it's going to be an instance method. When you see a dot, you know it's going to be a class method. And then our driver has some methods on it too. So driver.passenger names should return an array of all the passengers' names. And then .rides returns all the rides instances that the driver has been on. .name returns their name. Driver.all will return all of the instances of the driver. And driver.mileageCap takes an argument of distance and returns an array of the drivers who have driven over that mileage. Now, one thing I do want to mention is although you should be reading the README and creating these methods, like these are your deliverables, this is what we expect to see, that's not to say that these are the only methods that you should create, and that's it. If you want, you can always create helper methods for yourself. Maybe it'll be useful in this situation, or maybe we didn't explicitly tell you to create a certain helper method. So that's just something to be aware of. You're not just trapped to what's here. All right, cool. So one thing I like to do is have the README up like this, and then when we're working on these models, I like to copy and paste the deliverables like for that particular class, and then just comment them out or delete them as you complete each thing, so that way you kind of keep track and make sure you know what you've completed and what you haven't completed. So now that we know what this domain should be, do you guys have a preference of what to start with? Do you guys want to start with passenger, ride, or driver? Passenger? Cool, I like that. I like to start with the tables that are like on the outside. Just because the join one will require both of these tables anyway to exist. So I kind of like to make both of these first. Or at least start off with the initialize for both of them so we can initialize them. So, passenger. What's the first thing I should do to create the passenger method? Or not method, but the class. But before that, yeah, we should make a file for passenger. Alright, cool. So, class. Alright, cool. And then, so now that we've made the passenger class basic skeleton of it, maybe we can copy and paste this information over. A lot of stuff, right? But as long as you go one step at a time, you should have no problem tackling it. Alright, now what do we want to do? What would be the first method we should start with?
I like initialize.
I like initialize too. So, good rule of thumb, always, always, always make sure that you spell this method correctly. I've seen people mess it up and get stuck on a bug for like 10 minutes because other stuff is broken. Because your program, if you have this misspelled, it'll break. It won't read that there's any initialize method at all, or it'll have like it'll allow you to do .new, but it won't take any arguments. So if you're running into crazy bugs, just always make sure that you have this spelled correctly. Alright, so what should we have in our initialize method? Name?
Oh,
At name. Like this? Where's name coming from? Alright, cool. So name is an argument. What kind of data type would that argument be? Name as a string. So that's a good thing to keep in mind. Alright, any other variables? Simon? So you want to set a default variable to nil?
Yeah. But if I keep two, I don't know what the test is, but the test.
Yeah. So the thing about the test is that there are no tests. We're writing the tests. And our README says that we should always initialize this with a name. So I wouldn't worry about this too much, but it's a really good thing that you're already thinking in that area. So we can leave it. It's not going to impact our code, but you don't have to do this. All right. Anything else that we need?
Should we jump to the reader because it says right away it should be changed?
Yes. So that would be a good thing to do because otherwise we won't be able to see the name of our passenger. So how do I make a reader?
So attr underscore reader.
Cool. All right. Now, are we ready to test this? All right, cool. So how do we test this? It's saved.
Go to console.
Yeah, let's put something in here. So we have everything. This environment is set up. There's no tricks here during the code challenge. You won't have to require anything or worry about environment setup. So you can start putting your variables in right away. As long as you have a binding.pry on the bottom, or you might see like a pry.start or something. All right, so who wants to be a passenger? Simon? Okay, cool. So how do we initialize Simon as a passenger?
Boom.
All right, cool. So that's saved. So always make sure you exit your pry before restarting it if you've changed anything. So we have Simon here. So we can see, is Simon a thing? Yes, Simon is a thing. Make this bigger. That's cool. Oh, it's super easy, guys. It's just in terminal preferences. And then image, background. It's so easy. Alright, cool. So we have an instance here. Can we read the name? That's an important thing to check because we put the reader and we have a .name method that is supposed to work. So let's check if Simon .name actually is the thing that works. Alright, cool. That works. So just like one step at a time, make sure you're doing everything. So we got these done. We tested them, so we can take these off. Returns name of passenger. Alright, is there anything else we can do? Any other method that's feasible at this stage? Passenger.all, that's a good one. So how do we make this method happen?
First, you need to make a class variable.
Okay.
At all, so read the array.
Cool. And what is going to go into this array?
Every instance of passenger.
Right. So that's going to be our single source of truth for this passenger class. That's where we can find all the information about every single passenger. And how do we fill this array out? Where? Right. So every time we create a passenger, what are we shoveling? Self. Why self?
Shoveling each instance of logic.
Alright, cool. So we have this. But what about this .all method? Do we have a method like that? How do we create that?
New def. Let's call it self.all.
Cool.
What is it? It's all.
It's all. It's returning all. Very nice. Alright, so we made another method. Let's test it out. So we have passenger. It's returning an array. It only has one passenger in it. Let's actually make a couple other passengers just so we have some more robust test data. So who else wants to be a passenger? Jeff.
Jeff.
And one more.
I vote me.
Alright, cool. So now, so our passenger.all method is working. Nice. Yeah, so we can comment out this, now it's working.
Yeah.
Do we want to make anything else in this class? Yeah, my rule of thumb is once you have the basic stuff for one of these models, move on to the next model. So like probably better build out these outside ones first, just get the basic functionality, like the initialize, the .all, then move into the join, do the basic ones for that, and then maybe start tackling some of the methods that require you to go through this join. Alright, so shall we move on? Alright, which one should we do next?
Driver.
Alright, let's do driver. No, I don't want a folder. Alright, so how do we make this?
I'm lazy, I copy paste.
Class driver.
Class driver.
That's fine, we can copy paste, but
Unless you want to rebuild it
Go to the
again.
README.
let's go to the README. Alright, so our driver should have all of this information on it. What do we want to start with? What do we want to initialize with? All right. Name. Anything else? Yep. Cool. So driver should be initialized with name as a string. Now, do we want any kind of readers or writers? What should we add on here?
I guess you should do an accessor. You don't really specify.
That's a good point. So this is kind of up to you. Good rule of thumb, just about accessors versus readers and writers, is don't give your user too much power. So sometimes students are tempted to just make everything accessor, but just like think about the user experience going forward so that the user doesn't have too much power. In this case, it doesn't specify anything about whether it should be a reader or a writer, so it's kind of up to you if you want the name to be changed or not. In this case, we're fine with the driver changing names. But just that's a way to think about it, is not to give the user too much power at once. All right, let's test this one. Okay. Who wants to be a driver? Sarah. Oops. Driver.new. Wait, Jeff is a passenger.
You're a driver.
Zal? I can be a driver.
So we don't want to ever save. Yeah, we don't want to run out of initialize or any variable.
Yeah, I'm good with names now that I've learned everyone's names. Alright, cool. So we have our driver. Let's see if this driver thing actually works. So who did we make as our drivers?
Yeah, I would say like skip it with the required.
Alright, we're getting a driver instance back. We're getting their name back. And if we change name, does that work? But that was silly. Let's change it back. So all of the functionality is working. We've confirmed that it works, so we can take that off. Driver has a .name method. Now maybe it would be a good idea to tackle this one too, and just get it out of the way. So how do we do that one again?
Add all equals empty array.
Go to the internet.
And there's yeah, add all push self shuffle.
Yep. Cool.
And then you gotta create a method df self.all. Add all.
Cool. So let's just confirm that our method works. We didn't screw anything up. Alright, so that one works. We got that one out of the way. We have our single source of truth where we can find all of the drivers. Is there anything else we want to tackle at this point?
So this looks intimidating, but it causes
I don't think so, because all of them involve driving
Yeah.
passengers, so even though passenger exists,
Yeah.
there's no connection.
Yeah. All of them require going through other models. This one looks a little more complex. On the code challenge, I'd rather you guys get the basic functionality first before focusing on the more complex methods. So let's move on to ride at this point. So make a file. How do we make our ride? Class ride. Ah, that is not how you spell it. Alright, cool. And then readme says, here's what we want for a ride. Alright, so this one depending on how you view it, may or may not be more tricky because now you're kind of like incorporating other models within one model. So how do we tackle this one?
Self
What do we want to start with?
refers to this class. So when we're in this class, self
Cool.
anything without
And what does it initialize with?
It's going to be a driver, a passenger, and distance.
Driver, passenger.
Right? We're in this file.
Okay.
Here, like, yo, it's a file.
We'll do the
At driver.
Yep. So this is cool. It's like part of like this process. Like, oh yeah, crap. Okay, I'm not here.
So this is like a good time to make a mental note what kind of data you're expecting here. Like one way I've seen students mess up in the past is when you're doing your initialize method for like a join model, they might want to put like a driver's name or like a passenger's name, but according to our README, it should be the entire driver object. And that's like a more powerful way to do it because then you can get information off of that driver object. Say they had more information than just the name, then you can actually access all of that information. So we really want to join the two actual objects together. And then our distance, it's just a float. So just keep those things in mind. Does the order matter of how we define these things? Why?
You didn't like specify all the keywords, I guess, so that
Cool.
Mm-hmm.
what normally it does just take each one.
Would you like to go?
So the order can be anything here, and this order doesn't even have to match this order. The only thing that matters is when you invoke a new ride with like the .new, you follow the exact order that you've specified here. Otherwise, it'll, if you like had these two flipped when you invoke it, it would mistake the passenger for the driver and like the driver for the passenger. All right, cool. Now, do we want any readers, writers? Accessor? For everything? Okay, so this implies that after you initialize a ride instance with a specific driver, passenger, and distance, you can actually then go ahead and change the driver instance, the passenger instance, and the distance. All right, that's fine. Anything else we want to do?
I think we should just check it first, for like a
All right, cool. So if we wanted to test this code by creating a new ride, how would we create a new ride in our console.b file?
You just put like ride 1 equals ride
Mm-hmm.
whatever for that.
Yeah, let's double check the order. Driver, passenger, distance.
Driver, ET, like tower,
Yeah, the one thing I just like the proper way to do.
Mm-hmm.
passenger, ET, like sign and jump.
And every time I write anything, it's like because for me, I broke it in so many times. I was like, okay, class thing,
It has to be a
and
float.
don't forget you later.
Doesn't have to be. Has to be a number. It can have a decimal in it.
Quit.
5.0.
Okay, cool. Should we make another one, just in case? So, one thing I like to do, because it's a more robust way of testing, is like make sure there's a driver that appears more than once. So that eventually we can see like all the drivers. We'll make sure there's more than one. There's like a passenger that's more than one. Alright, cool. So we have a 2. Yeah.
Yeah. So.
Yeah, I need a charger.
short break.
What we do? 2 parts. One.
Thanks for looking out, guys.
Oh
no. Every day this happens.
But you don't have So
Please don't fall down.
I would recommend.
Yeah, mine died earlier, so
Yeah.
I'm a little.
All right. So maybe have the same driver appear more than once with 2 different passengers, and have the same, or let's say Jane, maybe have the same passenger appear more than once.
Two weird problems, too much stuff. By go to this problem you can solve makes everything easier.
Yeah.
The questions probably are in your head.
All right.
If I was-
Let's see if
I'd be like, all right,
any of our rides work.
so
Ride 1. That works. Now can we read the information? We can read the driver. We can read the passenger. And we can read the distance. Looks good. Is there any other method we want to build out on our ride at this point? So we have this because we've initialized. We can get rid of that. We can get rid of all of these because we're able to access the dot distance, the dot driver, the dot passenger. So we can get rid of all of these. Do we want to tackle this now or go somewhere else? All right, average distance. How do we make this method?
Before you can really do it, you need to find a way to save all of the rides.
Mhm.
Because right now they're being created but not changed.
That's a very good point. So how would we do that?
Same what we did for all the other ones. So you put at all, so it's a class variable. That's your
Mm-hmm.
inside of the initialize function. You want to also shove yourself into add at all.
Yeah. So that's one of those tricky things where the README didn't tell you to create the .all method, but it's probably a useful thing to create no matter what class you're making because you will probably need a way to access those instances, whether it's in this class or maybe in one of the other classes that needs to go into the ride class. So it's a good thing to have. All right.
A reader, I guess, for add So,
Do we need a reader up here?
Looks good. So,
not a
Paris
reader.
reading on straight.
Definition.
Done.
Yeah.
Who wants to go next?
Cool. All right. So we've done this a bunch of times now. Let's just test it out.
Love it.
Gotta make sure it works before we try a bunch of other stuff. So we have all these rides. If this looks like too much sometimes because it has like other instances attached to it, a trick you can do is ride.all gives you all of the rides, right? But then there's an array method that you can use like .length or .count or .size that will count all of them for you. So if you know you've created 4 and you have this huge mess and you don't want to count it all, you can do the .count method on it and then you can be like, okay, that matches with the information I put in. Alright, cool. Shall we do this one? Or do you want to do other methods from some of the other classes?
Now we do.
I think we can. But it might be Andrew.
Alright, okay, so let's go on to some of the methods in these other classes. Like maybe ones where a driver wants to see all their rides, or a passenger wants to see all their rides. And then maybe even ones where the driver wants to see all their passengers, so they'll have to like travel through rides. Or a passenger wants to see all their drivers and they have to go through the rides. So let's do some of these because these are pretty standard and it's behavior you're going to want to have. So if we're in the passenger class and we want to see all of the passengers' rides, build out this method. How do we make that one? Is it a class or an instance method?
Instance.
Why?
It's for the number symbol.
Done.
It is the hash symbol, but also, like, logically what tells you it should be an instance method.
Or because you're seeing how many rides that particular instance or passenger.
Exactly. Exactly. You're seeing all the ride instances of a particular passenger. Alright, so we can call a method called rides. So how do we figure out all of the ride instances of a particular passenger.
So you
have to iterate through the rides class.
Okay, so how so? Any ideas?
Rides,
Mm-hmm.
like capital R.
Rides?
No, rides.
Ride?
Yeah, right? Is that what you call that? Dot roll.
I think Lizelle had the same idea.
Dot select. What? I'm messing something up.
No, I'm just saying, I think Lizelle had the same idea.
Oh, I'm sorry.
No, I've been talking a lot.
Good practice for everyone.
You want, you can take over. Okay, so do the pipe. In the pipes, you write ride. Return.
Yeah, I like to put my ends. Return?
Yeah, they got that. I got this feeling going on.
No, I didn't mean return.
You can.
Ride.
So when you get that feeling, base, right? Yeah, skip it exactly. Good why? We're like, yeah, we need like stuff. Where
That
do we get this stuff from?
equals
Well, because we need positive names.
Ride
Where
equals
is
self.
that information?
No.
What does ride
Can
have
we do
on?
a pry there? Because like a lot of times I do a pry inside.
Right. Why is it good reference?
You want to put a
See what
binding
happens.
pry here?
Yeah.
We're like,
Okay,
yeah,
cool.
we want some information from here.
So if we wanted to access that pry, how would we do that?
So right now, even if I don't know that,
Pick one of the variables of the passenger.
Alright, say we take Simon.
So Simon dot ride.
that will come back.
Rides,
Okay,
right?
okay, now I
Is it rides or
No,
ride?
no, wait. It rides. Sorry.
So
Rides.
commenting that out, have a good life.
Alright, so we're hitting this method.
Yep. And then I would just type in ride just for now. Just to see.
Our driver has rides, so we need to like.
So what does it tell you?
So, buy rides.
Tells us driver,
Mm-hmm.
driver, passenger, and the passenger's name. So
Mhm.
we have
Gives us
pretty
like
much what we need. So we have to find passenger.
So how do we get the passenger?
So you go back to the code and put ride.passenger equals self.
What does that do for us?
That checks to see if it matches. It's gonna, I guess, create an array with that. It's gonna make an element of an array that's
awesome.
the whole passenger.
Alright, so can we put this in here? What do you think we'll see?
Oh, it's a boolean. It's like true or false.
Alright, false. Cool. So, can anyone tell me how the select method works? Lizelle?
So the way select works is that it'll take an array and then it will screw part of the array. And if it'll run that block, and if the block comes true, then it'll keep that in the array. If it's false, then it'll kick it out. So here you're putting select on ride.all. Basically all rides
Here it's like
I
Exactly.
just didn't know how to explain.
No, so this is a really important concept to understand because it's not going away. Like you're gonna have this kind of method in JavaScript, but it's gonna be called .filter. So if you have an array, it can have any kind of elements in it. Like it can have even numbers, it can have strings. In our case, it has like instances, right? So I'm just gonna put these like empty instances to represent the stuff that it carries, right? So this is an array. If we do .select on this array, the thing between the pipes will represent each element in the array, right? So each of these is like a ride. And you want to name this something useful. Like you don't, in this case, we don't want to just name it instance, even though it is an instance, because it represents a ride instance. So now, in this block of code, we have to put something that returns true or false. And it'll run this block of code for every single element in the array. And if it returns true, it'll keep that element, and if it returns false, it'll throw it out. So it'll run it through every single one, and when it's done, it returns a new array with like the filtered elements. And since each of these like objects is gonna have a .passenger method, this is like totally valid. It's valid code because every ride has .passenger, and every passenger we can check, does that passenger equal this current instance of passenger? So that's kind of how the .select method works. Does that make sense? All right, so that part is not going away, so we should keep that. All right, how do we test this? If we were to test this in our pry, what do we need to do? So who's a passenger that we have? Hi. Jeff? Cool. And Jeff has been on 2 rides. That's kind of why I was saying make sure you have a passenger that's been on multiple rides and like a driver that's done multiple rides, because then we can actually see if the array contains all of those instances. All right, so we have Jeff, and how do we check his rides? .rides. Not a trick question. So we have these rides. It looks like a lot, but it actually is just the 2 instances. And if you wanted to be sure, you can always do jeff.rides.count just to count the instances in the array. So we see that Jeff has one with Jane, Jeff has one with Lizelle, and that's accurate to what we have here. So it worked. Cool. Which method? Passenger. So we can take this off, because this works. It returns an array of driver instances this person has been on. Shall we do this one? Drivers? I think we're ready for this one. So is that a class or an instance method? Okay. And what are we trying to return with this method? What are we trying to do? Mm-hmm. All right, so how can we do that? Where do all of the drivers live? Yeah, they're in the driver class. They also exist on rides. So if we want to get the drivers of this passenger, any ideas of where to start? Go through the rides? Okay. All rides? Okay. And then? Lizelle?
Basically the same as the passenger rides.
Mm-hmm.
So you just put rides on all and select.
And what do we want from that ride?
Sorry, your color just threw me off.
Oh, sorry. I really like curly braces when it's a one-line method like this, because then you just keep it in one line. You don't have to do the do ends.
Anyway, each ride has a driver and a reader for a driver. You can put ride.driver.
All right. Here's the thing. What is self? Self is a passenger. So a ride's driver cannot be self, because that means it's a passenger, and it's always going to be false. So this will, in theory, return an empty array.
Okay, wait, I have a better idea. We should just call rides, right? Yeah.
Why do we want to call rides? Well, let's comment this out for now, so that's an idea that can hang around that we can talk about later. Why do we want to call rides?
This one has an array of all rides particular to the instance of a passenger.
Exactly. Because we don't want every single ride. We want just the rides that are to do with this passenger, the one passenger that went on those rides. And then we want the drivers associated with only those rides. We don't want every single ride. So if we use rides, which returns an array of the rides associated with that passenger, how do we get the drivers off those rides? Dot drivers?
No, I think we run select again.
Okay.
Yeah. Select, do, ride.
Ah.
So you have to put self.rides for it to
It's the same thing. It's going to look within what it has access to, and it's going to determine that, oh, rides, you mean this instance method rides.
Okay.
But yeah, self within an instance method refers to the instance, and self.rides is just going to do the .rides method of the instance. It's a little bit more explicit way of doing it, but you can do either, and it works. So I'm going to make that note. Same as self.rides. So what do we want to select? Hmm?
Oh, wait. I don't think it's working.
What do you think it is?
Map.
Yeah.
Why is it map?
Because we're not actually trying to change, like,
Mhm.
well, passenger rolling motorists are not rides. We're not really changing that number, but we are finding out what driver was for each ride.
Exactly. So here in rides, we've already selected and like filtered down this array of rides to only include rides to do with this passenger. Now we want to find out, well, who are the drivers associated with those rides? It's not something that we have to select for again or filter down, because we already have all of the rides. We want to know the drivers of those rides. So what map does is it goes through an array and it returns the same number of elements. It's not selecting or filtering that array. It's kind of transforming that array in any way that you want to transform it. So while select looks at every element and returns a Boolean depending on whether this expression is true and determines whether to keep that element or throw it out, what map does is it doesn't actually return a Boolean. What does it return? Yeah, so here you can put anything that you want, like any block of code to run, and it'll return this instead of the thing that was in the array. So if we had an array that was all rides, like this array is rides. If we do .map on this array, the variable here represents every element in this array, and we're going through every element and we're saying, okay, change this ride instance to ride.driver. So now we're transforming each element into the .driver. Alright, and it returns a new array. So we test if it works. How do we test it? So let's stick with Jeff. That drivers. So his drivers are Jane and Lizelle. And that's true. Alright, cool. So we got that to work. Drivers works. Now, it's safe to assume that if we wanted to get all of the passengers, all of the rides, or all of the rides, all of the drivers of a particular passenger, we probably want to have that functionality on the other side too. Like be able to see all of the rides of a particular driver or all of the passengers of a particular driver. So let's go ahead and do that, and maybe it'll be easier this time since now we've done something easier or something similar. So
this is going to save you.
What do we want to put? See, there's a, it wants a rides method. It's like, build me a rides method. It wants a passenger names method too. Which one should we start with?
Start with rides.
Why?
Because we're probably going to call rides again instead of passenger names.
Yeah, so this is kind of tricky. If you're just following the README and going one method at a time, you may or may not realize when you see a method like this, like, hey, I'm in driver right now, and I want to see all of my passengers' names. Well, in order to do that, I need to go to rides first, and the README doesn't tell you to build rides until the next method, so that's like something you should think about when you're building these methods. What do I need to make this functionality happen? Alright, so if we start with rides, what are we trying to return? We want all of the rides to do with a particular driver, right? Where can we get that information? Simon, do you know? We want all of the rides of a particular driver instance. So where can we get that information?
So we want the driver for the rides.
We want all of the rides of one driver.
All the rides for one driver. That's the one we drew. So we have all the rides against the driver. So we have to.
We don't have all of the rides, actually. We have the driver.
We have the driver.
So it's like the opposite.
Oh, so we have the driver and we sell one rides from the driver. Okay, so we would have to. Okay, so we have we're on the driver.
We're in the driver class.
Okay, so we would need an array of all the rides, filter
Right.
the select, and find the driver manager itself,
Mm-hmm.
and display that.
Cool. So what should I name the variable between the pipes?
Right.
Cool. And what should our boolean be here?
Not driver, or if they're riding dot driver, that's how we do itself.
All right. So we test it. I like this idea. All right. So who's one of our drivers? Maybe we can test one who's been on multiple rides. Luckily, Tara. There we go. That count. We expect 2. It's working pretty well so far. Alright. We're on driver. So we got this functionality to work. What about driver names? Slowly but surely, we're getting to the end. Or passenger names, sorry.
Now that we have an array of rides, so we're using it.
Mm-hmm. What do we want to do with that array? You want to map it. Why? What's your idea of mapping it?
Because we already have the array, so that we want to take one of those elements and get the deeper information for the passenger name for each ride.
Exactly. Cool.
So we will return the same amount of elements.
So for each ride, what do we want to transform each ride into? Ride.passenger.
Right now you're at the passenger instance.
Yeah. So I wouldn't make it yet. So
Don't worry about it.
Should we test this? Why?
This is how I figure things out. I'm going to click here. What am I looking at? Passenger.
All right. Let's think about this. So we're inside of driver. This is what our array of drivers looks like, right? This is what our rides looks like. So if we have a particular driver, Tara, this is what Tara's rides look like. If we run our passenger names method right now, the way that it stands, it's actually returning an array of filtered rides that belong to Terra. Did I not save this? Should be passengers at this point. Oh. I didn't run the pass. Oh yeah, I did. It is passengers. So these are passenger instances that are associated with Terra. But we actually want names, not instances in this array. How can we get the name of each of these instances? Is there a method on passenger that can give us the name? It could be a good time for like a binding.pry. I'll put a do this time. Let's put a binding.pry here. Anytime you're unsure, you can put a binding.pry and mess with all of the variables and kind of see what they are. So, Terra.passenger names. So we hit our pry. Right now we're iterating through rides. Ride looks like this. Ride.passenger looks like this. How do we get that passenger's name? You know this. It's not a trick question. What kind of methods does passenger have on it? Is there one that gives you their name? Well, this one is really the .new method. This runs when we call .new. So don't worry about this one. What's one that gives us their name? Is this one.
So it's my name.
Exactly. So.
Wait, so it is ride.passenger.name? Oh.
Because this right here, ride.passenger represents the name.
Settled on the name part, then you said the unique name.
So if we do ride.passenger, which is essentially this instance of passenger, you can totally call .name on an instance of passenger and it gives you the name. So does that make sense? All right. So we can do .name. Wait, I don't think I was supposed to do that there. Yes, exactly. All right, cool. So let's see what happens now. So we have two different names. Now, the method is asking that the names array should be unique, no repeats. What this means is if one of our test cases had like a repeat customer, so say Terra went on a ride with Rue again. When we call our method, Rue will actually appear there twice. Because we're just iterating through the passengers and returning the name. Yeah? Well, say it was a different ride. Like a different day. Oh shoot. Yeah, that's gonna overwrite things. Yeah, you're right. Thank you for catching that. So we're just looping over Terra's passengers and returning their name. And it actually shows Rue twice. But in our README, we actually want it to be unique. So we don't want to show the same passenger twice if they repeat twice. So how would we do this part? Having this array of names be unique.
I would create a variable and have it equal the whole size.map.
Okay, what do you want to call it?
we have a source of truth. Our ride, something our ride.
Just call it
So we
ride.
have like they have yeah. Yeah, awesome.
Like that?
Exactly. So let's just pause here and like test this. That's exactly right. This is why we have these sources of truth.
Passenger names, maybe,
Now,
so that we know that it's strings. Okay. So what's your idea with this? Where are you going?
So after the whole block,
Mhm.
I would just put passenger names.
Okay. What does that unique do?
It goes through and any like duplicates, it just gets rid of it. Just gives you the unique elements.
All right.
Just returns the unique elements.
That's exactly what it does. So let's just double check. Always double check that the code you wrote actually works. And it works. Another thing about .unique is you can actually chain these methods, so you could just do .unique there if you wanted to, and that would also work. Or if you had one of these with the curlies, you can even do .unique there. So these methods are chainable, which is something to keep in mind.
But it wouldn't be. You can
Yeah, let's
unique
go
it
back
here.
through it. Awesome. Yeah.
Well, it doesn't make sense to put it here because it's an array method. And right here, we're inside the block of code. We're not operating on an array in here. We're actually operating on an instance.
That works.
This thing returns the entire array. So we do our .unique on the array after we have the array that has all the names. All right, cool. So we did that. Passenger names works. Which one do you want to work on next? Now it's kind of like the more slightly complex methods that remain. Actually, I think there was one in passenger that we could have tackled. Like, in order to add a ride for a passenger. That's a good one to do. How we do this one?
Look up all the rides around. Beautiful. So I have
Okay. Does it take any arguments? It looks like it does.
Driver distance.
Mhm.
Each ride are kept. Because like this is all so we try to
And what kind of data types do you think these are? Both?
I think these go inside. I could be wrong.
These go inside add ride?
No, not immediately after.
What do you mean?
We continue building it and see if I need more.
All right.
And then
So good rule of thumb, the README will be pretty explicit. So like for instance this method passenger add ride, it tells you the arguments right here that it takes. So when you're defining the method, you give it the arguments right when you define the method. Right? That's what we did with initialize.
oh, never mind. I got
And it tells you what the data type should be. So what should the driver be? What kind of data type? Is it a string? Like, is it the driver's name? How do you pass in the driver?
I would say object.
Exactly. So both of you are on the right track. It's the object.
So it'd be right. Change the classroom.
You're right.
Start here?
No, I mean like the code.
Here? Okay. Ride?
Yeah.
Cool. And what does that new take?
Arguments of self, because we did passenger driver distance, right?
Driver, passenger,
So
distance.
driver self distance.
And so passenger one.
So the driver, which is passed in. The second argument is passenger. Who's the passenger in this case? Self. Because we're trying to create a new ride instance for this passenger, and this passenger is self. And then?
So
Alright, I like that. Let's test it out. So, it looks right, but always a good rule of thumb to test everything. So if we wanted to take a driver, or is it passenger? It's a passenger. So if we wanted to take a passenger, like Simon, and we wanted to invoke the add ride method, what kind of argument should we give him?
First one is driver.
So let's pick.
So, yeah. And then?
5 for distance.
5?
Yeah.
Okay, so that looks like it worked, right? The new ride was created. Cool. So that method works. We can take that off. Alright, shall we finish out these? Which one do you want to do?
Can we see the other classes see those are...
So there's a mileage cap method for driver. Takes an argument of a distance and returns an array of all drivers who have driven over the mileage. There's a ride method left, that's a class method. Returns the average distance across all the rides that anyone has ever been on. And for passenger, we have a total distance, returns a number representing the total distance a particular passenger has traveled. And then a premium members class method that returns an array of all passengers who've traveled over 100 miles.
They're all like...
They're all slightly more complex, more fun. So these kind of methods I would focus on last if you're on the code challenge, because I'd rather you guys get all of the functionality, the basic functionality working, before tackling some of the methods that might take a little bit longer. I think at this point it doesn't really matter which one we start with. Do you have this? Yeah, let's do total distance.
So it's an instance method. Travel using this. Okay, so what we want is to look at all the rides that the passenger has traveled.
Okay.
And then
Me, it's all rides.
And then we, for each of those rides, it has a distance already, so we need to kind of collect that or
Collect the distances
right, and add them all together.
from all rides, add them together. It's a good way to make a little roadmap so you know what you're doing. Alright, so where can we start to do this? How do we change this into code?
We could put rides, right? I don't remember if we'll just get all the rides.
We have a rides.
Yeah, so we can invoke that. Actually, before that, can we make like sum equals 0?
Sum? Yeah, that's a really good way to start, because then you can start off a variable from 0 and you're just going to collect every distance as you hit it and as you iterate over.
So rides.each, actually, I just don't know how injected values works. I'm sorry.
Dot each is fine. I would rather you guys do it in a way that you understand. So what do we want to do to each? What do I want to put between the pipes? Ride.
Okay, so ride dot distance.
That's true, right?
They put sum actually, sum, and then plus equals ride distance, yeah.
So why do we want to put sum on the left side?
Because the way plus equals actually works is that it's like saying sum is equal to sum plus ride distance. And what we're actually doing is taking every distance and then just putting it
Exactly,
sum.
exactly.
And then after that, you want to write sum so that the actual thing returns.
Exactly. One thing I see students frequently mess up is you're used to seeing methods like this where, alright, I'm doing something to this ride that I'm iterating over. I'm doing something to this ride, I'm checking its driver. So it might be a little bit counterintuitive that we're not actually doing something to this ride. We're actually doing something to the sum. Because this right here is just the block of code that runs with every single instance. So you don't necessarily have to do something to that instance. We're actually doing something to sum where we're adding that distance to the sum. If we were to do it backwards, we would actually be overriding the ride's distance. We don't really want to touch it. We just want to look at it and add it to the sum. This is a good way to do it. Let's see if it works. So this is a passenger method. Who do we want to test it on? All right. How many?
Let's do me.
Yeah.
Okay, cool. So that should be around 12. So root dot. What was the name of the method? Total distance. Right. Looks great. There is an inject method in Ruby. I don't 100% remember how to use it. So we can look up Ruby. You can use inject. It basically allows you to add everything up or do other operations to it. Yeah, so it can take an array or a range, because a range is essentially just turned into array, and then you do dot inject on it. And then this is like your basket where you keep collecting stuff, so like your sum. And then this is each instance that you're iterating over. And I believe it'll just start with whatever the first number is, and it's going to keep adding it up. Or another way is you can specify a specific number that you want to start at. So like if you want to start your sum at 1, and then it's kind of the same thing. You specify how you want this thing to grow. So this is like the sum that keeps growing, and then what operation you want to do at every single iteration. So I think something like this may work. You can test it out. I'm a big proponent of knowing how to write it yourself, because if you can write something like this yourself, then you truly understand how it works. But if we wanted to try the other way, so this way works. Thanks, Lizelle. If we wanted to try the inject way, what are we iterating over to inject?
There it is. Right? That's what it is. And we're saying ride that path tree. So
I don't know. I think this would have to be, this is the number that we're trying to add together. I think this is what's in the array. So this is like our ride. So for each ride that we touch, we want to add ride dot distance. This might work. And this would like start at the very first number that we encounter, and it'll just keep building up as we go through. Let's test it out.
here's the next iteration. What is this ride?
Who did we test? Root
So I go to ride
dot
passenger
total
and speed. That equals
undefined method plus for ride. Okay, so I think what it's saying here. Anyone have any ideas before I give it away?
Can we go back to what we wrote?
Oh, we didn't define sum.
No, this is. So I think what's happening is sum is actually starting at ride. And ride is an instance, and you can't start sum at ride. So I think we actually do have to specify that we want to start at sum. That's my theory. I'm not much of a Rubyist. I much prefer JavaScript. You'll hear me say that a lot. But I'm learning. Alright, so this way works.
And that's easier than what I wrote because it's only one line, and you don't have to specify that you have to return.
So that's
Yeah, but I think it's a good way to also know how it works. Yeah. So this works. Premium members. So we don't actually have anyone who traveled over 100 miles. So why don't we go ahead and change our data so that we actually have people that traveled over 100 miles?
Add another 0 to it. And another 0.
Where are you? Alright, cool. So you'll be a premium member. Maybe someone else should be a premium member too, just so that we can make sure our array has more than one person.
All the rides.
Let's do Simon. Simon can travel 100 points. I don't know. Something like that. That'll work. Alright, so we are on. We're not there. We're here. Instance or class method? Simon. Is this an instance or a class method?
This would be class because and it's for all passengers.
Exactly. We need to look at all of the passengers to determine which ones traveled over 100 miles. So, how do we write a class method?
So you define for that self dot
Step one is give me all the rides. So we have one ride, we have two rides. Now that I have the rides, turn them into drives.
all the numbers or all the passengers.
Mm-hmm. So, like this? Passenger.all?
We or you can set
All
rides.
the
Ride, drive to ride.
You can do this. It's the same thing as doing self.all. So self inside of a class method refers to the whole class, and our class has a self.all method. We can also do passenger.all. It works exactly the same.
Can't you also just do
I think you can. I have a feeling that's not good practice, but I think you can, because you can access this within any method.
define self.all?
Yeah, so this is, you can't access this from outside the class, which is why we wrote the self.all. So if we wanted to do like passenger.all and see all of the passengers, we couldn't do like passenger.at@all. This is only available within the class. So I think you actually can do at@all here too. So all of those ways work.
So we go through every single passenger
Okay.
and would need an array or a list of all the premium members. So we would have to do that.
Need array of premium members.
So we do self.all. Actually, no, not select. We're going to filter out every instance or every member that is premium.
Yeah, that's a really good way to think about it. Anytime you need to filter things down, like put it through a funnel, that's a good indicator to select.
And then you would do, and then for each member,
Okay.
or
What are we looping through?
we go through each passenger.
Yeah, it might be better to just put passenger so you don't confuse yourself later, because we're very familiar with the methods that are on passenger.
What we're looking for is if the distance total is greater than 100.
So,
So we would.
do I need an if?
No. So we would use this is okay. So we would do a large list of
Just the ones I care
so
about.
we would say if passenger
One, two. First two. Rides.
dot total distance
So now that I have
greater
that
than 100.
two items, I don't need to find a subset. I can use that.
Actually, I don't think you even need it
Yeah, you don't need it.
because we're using select. That's it.
Exactly. So select will just check this statement for every single passenger instance and evaluate if it's true or false. And it'll only keep all the true ones. And it'll return an array for which all this, or for this, for which this is true. Alright, let's test it out. How do we test this method?
It's a class method, so you type passenger dot
Premium method. And we have two of them. We have Simon and Rue. And that looks right. Cool. So that method works. We've completely finished out our passenger class. Nice job, everyone. So what about driver? What do we want to do here? How do we do this mileage cap method? Is it a class or an instance method? How do we tackle this? What makes you say that?
It's just not there.
Yes. But this is a good indicator too, right? It wants to look at all drivers. Alright, cool. So, def mileage cap. What's our argument? Distance. Yeah. And this isn't a trick question. The method will tell you what it wants you to take as an argument. What's the point of that argument?
To compare it against the array of the drivers. When we have to turn this to
So what this means is that when you invoke this method, make sure you pass it a float, like some kind of decimal number. Return an array of all drivers who have driven over the mileage. So we're inside the driver class. We have access to all drivers, but we only want the ones who've driven over a specific distance, and that distance is indicated here.
So let's get the drivers, all the drivers first.
So driver?
All.
Driver.all?
Not driver all.
They both work.
Self, O.
Mm-hmm.
The array of all drivers.
Exactly.
And only the drivers have driven over a specific mileage.
Exactly. So what method would that be? What array method would be appropriate there?
Select.
Great. Cool. And what are we looking for about that driver?
I don't think we have a function that like gets the total.
So we don't.
Mileage.
Do we have a function that gets the total distance a driver has driven?
No. It would probably be better to write a helper method.
Let's write a helper method. That's a great idea. Otherwise, we'd have to kind of like write two functions in one, and we don't want to do that. So, total distance? Didn't we write something like this before?
That we did.
All right.
Copy it over this or something.
I think that's fine, because you've already written it already, so if you know how to do it, I have no problem with you copy-pasting methods that you've already thought of yourself.
Oh, so this method I have no idea. So, you gotta.
You want to do the other way?
Isn't that it?
Rides distance. Well, okay. Sum for ride. That would give us something for every driver. Yeah, let's say it works.
Let's test it. Yeah.
Let's say it works.
I think it'll work because rides is also a method that exists on the driver, and it'll go through that driver's rides and it'll add up the sums. So, how do we test this?
You should call rides first, just so you can. So, James, rides.
So I have two rides. Distance 5 and distance 100. So I should get 105. We're testing total distance. I'm getting what I expect. So this method works.
Cool.
And now this is a method that every single driver has access to.
So now we go back to the building. If we just do
Oh, total distance.
Which one?
total
Why?
Because now we have
Yeah.
so now we know to build it is greater than what is it? Oh,
This.
greater than distance. Yeah.
What's being passed in?
Yeah.
Yeah, that's okay. So
All right.
what I would do,
And that's
I'm in this,
that.
I'm like,
So now if we call
Yeah, so this should filter all of the drivers
source of truth,
whose total distance, which is the entire distance that driver has driven, is over the specific mileage cap or distance that was passed in. So let's test it out. Who's a good candidate? I don't know. Maybe we can find one where we can like return 2 drivers.
We can test over 50.
Yeah, I mean we can test it on a few different ways. A few different ones to see how it changes. Let's do that. So driver. Oh, it should be a class method. Driver dot mileage cap. So who's driven over 50? Tara and Jane.
On the bottom too.
And that looks good. Who's driven over 0? That should be everyone, right? Who's driven over 100?
Really hard stuff. And
Let's do 110.
by the way, also just
Nice. Cool. So it works. That was kind of a unique one. Nice job, guys. Just one more left. Ride. Average distance. Class or instance method? Why?
Because you're doing a specific ride, so not all
I
rides.
don't know why. Let's just go crazy.
Okay, but average implies you need to look at multiple rides and one ride.
Now you mentioned we're in one ride.
Yeah,
So it would be a class.
exactly.
How do I know?
Average distance.
Right now, this is the same. Driver dial.
So basically we want to look at every single. That's a good point.
Cool. Let me see this.
Yeah.
Right now, our
All right.
functionality would be like every single person who says we were just going to return back.
You can go ahead.
Sure. Okay, so we need an array of all the distances.
So need all distances.
And to do that, we would.
Do you think that all distances should be kept in an array? Or
Yeah, we can put an array so we can inject it and we just sum each one in turn. And
Okay.
by dividing by the total
Okay.
number of instances.
inject array to get sum of all instances. Which array would we be operating on?
Of all the
Needs
distances.
to go through the ride.
So,
Is that an array we have access to? An array that
let me
has
see
all the
what
distances.
methods we have in the right.
All we have is this array, which is ride instances.
So can we just call the distance from
Exactly.
the
Exactly. Yeah, do you want to try and implement that?
yeah, we can call the distance from all of the rides.
Okay, we can. So how do I start this method?
We would just do ride dot all
Okay.
dot actually I think we can also do dot distance.
Like
Would
this?
that give you all the distance from all the rides? And then
I want all the drivers.
So what kind of data type is ride.all?
Returns an array of the driver instances that this person has rode with. So driver.map.
If you're not sure, we can always put a binding dot
Ride
ride.
all is an array of all the rides.
Exactly. Ride.all is an array. Can we call dot distance on an
No,
array?
because that's first. Yeah. So
Exactly.
We would have to go through the first letter. So ride all select.
So what does select do again?
That would just find if it would just go through every single element of the array.
Mm-hmm. So it'll go through every element and do what with select?
Oh, so we get the right there.
So I'm asking.
We go through each independently, and then if we get the
As Kevin.
So
we do the
select.
sum of all the. Okay.
Which driver?
Yeah, we want to get every single distance. What select will do for us is like filter an array to just get certain instances. But we actually, in order to get average distance, we need to sum all of the distances first. So we don't want to just get certain rides. We want to get all the rides first.
collect.
I'm gonna delete this.
You want to do collect? What does that do?
I'm just trying to figure out how we can get an array of rides from this.
So, before we do this, let's think about our approach first. I'm a strong believer that if you work out your approach logically, like try to solve the problem logically first in your native language, which is like problem-solving skills, as opposed to in your foreign language, which is code. So if you can think about it logically first, it'll be a lot easier to translate into code. So how do we get an average of anything? Well, we need to add up all of the things. Well, in our case, things is actually distances. And divide by what?
So relevant rides is great.
By number of rides. Exactly.
So in this case, when we keep account, does that help? Just 'cause it's a number?
That is something you could do. You can have like a little basket that you initiate and go through every single ride and put its distance in the basket. So that then you have this number that represents all of the distances. Then you can divide by the number of rides. So, anything else you want to add to this approach, or keep it simple? Like, any more details? Like, where are we getting these distances?
Right between these two lines.
All right, let's do that.
How about we access a way to get all the distances?
So access distances from where?
That array of rides and
Access rides. Yeah, that makes sense. Access
From rides.
so we want to do this.
So if we're accessing distances from rides, what is rides? What do you mean when you say rides? All rides. So rides is an array, right? So what does that mean we have to do to that array?
map into it.
Use some kind of iteration
Some iteration
to
to get to
collect all the distances from rides array. This can help us, right? So now that we have this basic approach, how do we actually code this out?
distances. That first part would be
Can I do the inject way?
You can. I would recommend doing the manual way first. Like, how would you manually do this before we get into like the shortcut method?
So let's try it and we'll walk through that.
So it seems like our plan is to take all of the rides
Okay.
and convert each instance of the ride into its distance, so that we have an array of distances.
So how would we do that?
Ride.all.map.
Mm-hmm.
So that's the one that's driving.
Each ride.
Got a driver's back. Cool. Let's
Ride.distance.
bust it out. So thank you for walking through that.
Yeah.
So then we have something like that.
So make it self-auto.
We cannot go drive.
You can do that.
Yeah, I was gonna say, can we just do this and then get the
You want to inject this?
Yeah.
We can do. Okay, fine. Now that we've moved down that path, we can do it this way. Okay. So how do you want to do it, Simon?
Exactly. We skip the whole relationship. Yeah. Now
inject.
this is why like we learn more trying to.
So I don't think 0 even matters at this point because our distances is already
You learn more like
an array of numbers.
oh, cool, you need to
Alright,
join
so
my-
yeah, then we would do
Alright, I'm trying to
the brackets
That you know, and then after a while,
Mhm.
and just say n or number
have
for
the relationship.
So that's our distance, right?
yes. And we do sum
That's why we call it group.
plus n,
We say
Mhm.
and then outside the bracket we can just
in
do
order to
divide
go
by
to go from passenger to driver, we just
Distances
go
dot
through the
count
ride,
or
we
dot
follow
size.
the rides, and pull the driver out.
and that would give you the full sum.
Exactly. Yeah.
All right.
So yeah, this.
So let's see if it works. I think that this will work.
Do that.
We're mapping our rides
Yeah.
into an array of just numbers that are the distance of each ride. And then we inject, which means we add that array all up into just one number, which is the total distance, by having like an argument that's our basket that collects all of the things, and on the iteration we add the distance for each ride. And then once we're done with this entire operation and we just have one number, we divide it by the total. Cool. Alright, this is an instance or class method, right? What was the name of it? 39.43. Do you guys think that looks right?
We should.
Do you want to test it? Oh, okay, so it's 50. I can do it, I can do it. Actually,
I would say it looks right.
you guys want to be let in on a little secret? You see this IRB thing? You can do math in it. Every time I do my budget at home, I open up the JavaScript version of Pry, which is called Node, and I just do all my math in my terminal. It's okay. 100.8. 236.6. Cool. So that works. I do want to let you know about the more like manual way to do it. Also, this is a little bit redundant just because we have a way to inject using the ride distance. Like if we had ride here and then like ride.distance, that would work too. A slightly more manual way to do this is if you had like your sum variable that you start at 0 and then you go over all of your rides. So self.all and then do like an each. And then for each ride. Is this how you Ruby? I don't remember how you Ruby. So if we're going through each ride, you can do like sum plus equal ride dot distance. So that's kind of like what we did before, one of Lasalle's methods. And then once we've done all of this, we can divide it.
Oh, divide.
I mean, we don't have to do it there. That's a little bit ugly. Oh yeah, you can't. You'd have to do sum. Yeah, you'd have to do sum over distances. Self.all count or something like that. So that should work.
Does it matter which way you choose, or do we have to use like injecting or
It doesn't matter which way you do it as long as you understand what you're doing. One of Matt's favorite quotes that I think is really nice is never submit code you don't understand. Like it's okay to like copy and paste code you don't understand sometimes, but then like analyze it and make sure you understand it. But don't like push things to GitHub or to your code challenges where it's code you just don't understand. So I would much rather you do it the more manual way, if that makes more sense to you, than using a quick method that's built into Ruby, like inject.
Cool.
Alright, nice job guys. I'm going to push this to GitHub and send you guys the repo so you can look at what we've done today. I've also recorded this session if you want to look at a video of it to review. Does anyone have any last minute questions?
Yeah, just a question on this last one. So instead of calling distances equal to the numerator, can we just do self.all at that?
Yes, probably. What do you want to do? Self.all dot.
Yeah, so the whole thing right there. Ride dot distance. And then just do dot inject something like that.
So I would say an even easier way to do this is why not just inject right away. So you have your array of all the ride instances. You can inject starting from 0, right? And then you have your sum and your ride. This is the thing that represents each thing in your array. And then we can do sum plus ride.distance. And then we can divide this by distance of size. Or self.all.size.
Would that work?
This would work. So self. So this is a little bit ugly. It's a little too much for one line, but in theory, this should work. So. There we go.
Ooh,
All right.
3 ways.
Cool. So now you guys know how to solve it. I think that's it for today. All right. Thank you, everyone.